Hello, this is Jason from Access Fixtures. Today we're explaining how mercury vapor lamps work, why they're now obsolete, and what you need to know when replacing them with LED lighting. We'll explore the science, performance issues, and real-world calculations so you can make the right lighting upgrade. If you find this video helpful, like it, and subscribe for more lighting insights. Now let's get started. A mercury vapor lamp is a gas discharge light that uses an electric arc through vaporized mercury to produce light. The arc is inside a fused quartz tube housed in a larger soda lime or borosilicate glass bulb that insulates heat and blocks UV radiation. These lamps deliver 35 to 55 lumens per watt and last around 24,000 hours. That efficiency made them a top choice for large-scale lighting, from factories and warehouses to sports arenas and street lights. But color quality was an issue, especially with the greenish-blue light from clear versions. Clear mercury vapor lamps emit a greenish-blue glow, which distorts skin tones, not ideal for retail. Color-corrected lamps use phosphors to improve color rendering. Still, these lamps require 4 to 7 minutes to fully warm up and reach operating brightness. Here's how mercury vapor lights compare to LED lighting across 6 key categories. Lumens per watt, mercury vapor outputs 35 to 55. LED 120 to 185. Color rendering 30 CRI for mercury vapor versus 70 to 90 plus for LED. Startup time. Mercury vapor takes up to 7 minutes. LED is instant on. Dimming, not possible with mercury vapor, but fully supported with LED. Mercury content, mercury vapor contains it. LED doesn't. Solar options, mercury vapor has none. LED does. In every category, LED is the clear winner. Mercury vapor lamps are now considered obsolete. They're less efficient, offer poor color balance, and require bulky ballasts. Production of these lamps and their components has stopped, making LED the only viable replacement moving forward. A 175-watt mercury vapor lamp may still light up years later, but with severe lumen depreciation. For example, after just 1,200 hours, output can drop 15%, from 40 lumens per watt to just 34. The lamp keeps using 175 watts, even though it delivers a fraction of the light. The fixture type affects delivered light. An open dusk to dawn fixture might deliver 95% of lamp lumens. A full cutoff wall pack may only deliver 65%. When replacing with LED, it's the lumens, not the watts, that need to match. Here's how it breaks down. Start with the lamp wattage, 175 watts, and multiply it by 35 lumens per watt. That gives us 6,125 lumens when new. Next, factor in 15% lumen loss after 1,200 hours. 6,125 times 0.85, which equals 5,206 maintained lumens. Then apply the fixture's efficiency. In dusk to dawn and barn lights at 95%, you get 5,206 times 0.95, which is equal to 4,946 lumens. In a full cutoff wall pack at 65% efficiency, it drops to 5,206 multiplied by 0.65 equals 3,384 lumens. That's why, when switching to LED, you need to match the actual delivered lumens, not just the wattage. Mercury vapor lighting served its time, but LED lighting delivers the efficiency, reliability, and performance that today's applications demand. Access Fixtures' high-performance LED solutions offer better light quality, lower energy use, and long-lasting durability for commercial, industrial, and outdoor environments. Visit accessfixtures.com to find your ideal replacement, or call 1-800-468-9925 to talk with a lighting specialist about your project. Thanks for watching. Don't forget to like, subscribe, and let us know your thoughts in the comments.